So in this video I try to show you guys the FDF project overview. So basically I am a student in 42, and as you guys can see in this graph, you can see all the projects you were supposed to do. Then there is push swaps, and this project has a very good guide created by my friend Oceano. And then this is one of my inspiration to try to start making this video about this other project. Like you guys can see, Oceano, it's a fairly known YouTuber around 42. Try to make a guide for this on this second ring. Most of the people are doing this project. It's Solong. Solong project is basically creating a 2D game in C. These other projects, FDF and Fractal, are like overlooked by most of the students in 42. So I didn't find any very guide or YouTube video on YouTube. So I want to make one, since there is not a lot of documentation online and all the documentation is pretty old. So I found this blog post on Medium by Bell. Well, this guide is very good, and I'm gonna leave this link of this blog post down below in the description. For now, let's just go over together. It's one of the first graphical projects at 42 network. Basically all the projects like Solong, the Little 2D game, FDF and Fractal, these three projects are supposed to teach you how to use the graphic library. The goal of this project is to introduce you to graphics, and especially rendering and transformation. Basically, we are given a map as a file, more about it later, and we have to transform the map into a 2D graphical representation, rendering like that. So this is the example. So this is MLX42. Understanding the map format. First, we are given a map with the following criteria: the horizontal position corresponding to the x-axis, the vertical position corresponds to the y-axis, and the value corresponds to z-axis, and an optional color RGB separated by a comma. For example, 0, 1, 2, 3, comma. We have 4 points from left to right and top to bottom. We are going to name them according to the alphabet: A, B, C, D. Point D has an optional color set to white. So this is an example of the map. This is in 2D. You guys can see here the map. Alright, I think it's so far for this introduction is enough. I'm gonna keep going later on.
Let's go. Let's try to see if I can explain my FDF. You guys can see there was a little bit of gap in between the first video when I was doing a project overview and now that I finished the videos. So I'm gonna try to explain what I did. So let's go to my GitHub over here. This is the main body of the function where all the process starts. I start with parsing the map and I start with creating the windows. So you can see here I have the two structs I've made. The first one is the linked list, so it's the data structure you need to store the value of the points. I decided to use a list, and I'm gonna say that this is not the best choice you can make. You should use an array or something else. The lists are not well optimized for this project. And then I have a tdate info map where I store all the useful information. And then there is this other flag. Yeah, mainly it's just for checking purpose. To save a line, I create int values as a flag, and these two return 0 if everything is okay, and return something else if there is some error. So if this flag is different than 0, it's gonna exit the program. So yes, this was the final version. So you can see I try to optimize the line. Here I have this if statement that states if you pass to the program less than 2 arguments or more than 4 or equal to 3, it says not enough. It's because I try to make a little customization about you can give a set value for the window size. So if you want a bigger window, smaller window, you can do that. And this was because the beginning of the this project, I was with the mindset of doing the bonus, but then I realized I don't have enough time because I waste so much time on the project, so I decided to skip the bonus, but this little implementation stayed. So basically check window size is gonna check for these two parameters passed from the command line, and if the check window size I'm gonna show you real quick. So yeah, check extension is basically just gonna check for the it's gonna do a string compare with the extension we want, so .fdf4, and if it's good, it's gonna return 0 printf the file extension is good. Otherwise, it's gonna return 1, not a valid. Check the window size. It's basically gonna check if it just pass me some values that are digit and not the letter. It's gonna do the same thing for both the string. And then this is check them up. And I have checked the FD and check them up. This basically just for norminet because this function is gonna be very long. So check the FDF. It's just gonna open and check if the FDF is -1. If it is, it's gonna exit the program. Otherwise, it's gonna just return the file name. So here in check them up, I can open the checkdf with file name, and then I set up this loop with the get next line.
I will try to be the clearest possible about this explanation over here. We are inside the check them up static function to check them up, and I declare some variables here. Let's pay close attention to rows and columns. So they both start at 0 over here. Then I open up the map, which in open, check the FD, and then we are inside this Y cycle. Helpline is gonna always call get next line with the same FD. As soon as we finish reading the map, we're gonna break all the loop because get next line is gonna turn null, right? So we're gonna start with the first line. The first line is gonna split, and then it's gonna send to matrix map. And then we're gonna increment the rows, so the first counter in matrix. Let's try to explain. So split is gonna take this as a string. It's gonna split from the word. So this is gonna be number 0, this number 1, this number 2, and this number 3, right? So basically this is the same thing is gonna go with our map. So let's say we have a map of 0, then we have space another 0, then we have 1, and then we have 1, 0. This is for the first line, right? So if we call split with a space here, it's gonna return a 2D array, right? But we actually don't care about the how long a word is, right? Because we're gonna pass it the whole string as last parameters of create list. So we passed head, rows and columns. So here there is no clear incrementation of columns, just because I had to follow the norm, and this function was going to get very long. So here increment and free, basically it's increment columns, and then it's freeing both helpline and matrix map, because helpline is getting get next line, the matrix map is getting split, and these two need to be free. Alright, this Y is gonna be true for each single word. So let's say like this, right? It's gonna iterate through the rows, and then you're gonna say like here rows is 0, here is 1, here is 2, here is 3. And what it's gonna do is gonna say here the row, and then maybe it's 4 because it's new character, right? So it's gonna go here the rows is 0, it's different than now, yes. Then we're gonna send rows as a 0 as an index, columns that still 0 because we didn't increment it, and then the whole string. But regardless, we send the whole string, and then we increment rows. And this is gonna get increment until we find the end of the 2D array. So we're gonna increment like 0, 1, 2, 3, 4, and then when we reach 4, it's gonna done. And then what we're gonna do? The rows is gonna go back to 0, and then we need to increment columns. Why do we increment columns just now. So we set rows back to 0, and then we need to increment columns, because here, and then we're gonna do we're gonna read another line. Why this? So for each, like if we draw this graph like this, where this is the x and this is the y. Okay, let's try to. Okay. We increment x for each word we found, like 0, 0, 1, 0. We need to increment x, right? And then we increment y, as long get next line doesn't return null. So if we have 3 lines, we need to increment, like we get null here, we go back to 0, we increment columns because we get 1 more columns, and then we keep going until we find null. And in the end, when we get null, it's gonna break, right? It's gonna break out of the loop. You see? Get next line, return null, we break out, and we don't increment columns. So we get columns and rows right. Because when we launch create list, we need both values, columns, rows as x and y options. I hope this video was a clear explanation, because I actually have troubles trying to explain this before, but now I hope it's clear. So you guys get like, so let's go in the simple case where like we have 2 1s here, 1 0, and then 0 0 0. Okay, so we have to go line by line. So get next line, take this first line, and then it's counting how many words, like get splitting, it's count how many words. So we have 0, 1, 2, 3, and then 4 is now. So we're gonna send like the index 0, the 2 0, like here is 0 0, position 0 1, 0 2, 0 3. Then when we're done, we get 4 rows is gonna go set back to 0, and we increment the columns because get next line still give us something to read. And then this while loop is gonna continue as long as we get the map to read. So yeah, that's basically it. In the last part of the explanation, I was explaining what was going on with the parsing of the map, and it was actually one of the most difficult part of this project, FDF. So after explaining how I was able to use both split and the function get next line to get the x and y values, let's move on to the create list function. Vim parsing, let's see. This function create list, basically what it's gonna do, it's gonna get the 2 counter I explained just a second ago. Create list takes the head of the linked list, x and y, and then the last parameter is a string. It's gonna be the z. Here you can see we're gonna check for commas, because the map can have the commas inside of it, and after the comma is gonna be the value of the color we want, and before the comma is gonna be the actual value of z. Because I don't know, I think I already explained how the map works, but basically the position x and y are like the index of the 2D array that basically the map is, and then the value of the char, it's basically the z value. Then we set up the y and x pixel to 0 and go right, go down, and next to null, basically. And then we assign the next to the next node. So basically, go right and go down, those 2 pointers are the one we need to create our map, to link the points to the left, to the right, and down. Here we have function to free the list, doesn't matter to math. Check account is basically just check for how many points we have in the entire list. So info to list, this was just a small function I needed to nominate, because I had a function that needed 5 parameters, but I have to respect the school indentation nominate. So info to list is basically just gonna assign to each node a reference to the info structure and then we have point connect and space scale. Okay, let's go to point connect. So if I go with make, it's gonna compile the project, right? Those are all the warning, they are in the MLX library. Okay, almost there. We can do a quick check. You see if I open without param, or like if I try to put 3. Let's try with a good extension like mapio.fdf. It's gonna say the file extension is good, but you cannot open since it's not a16. So let's try to show you guys what it looks like with a real map. So I go FDF maps, and then if I go tab, you have all this map, and I'm gonna show you in a minute. This is the, and if I press space, it's gonna pop up and say some key pressed. I was trying to make bonus, and for bonus you have to handle different key, like for zoom in and stuff, but in the end I didn't have enough time, so I just quit it. So I was explaining how to do the parsing. My parsing was not very efficient, so I highly suggest you guys to do like me. I just want to share with you the ideas. So yeah, we were explaining about info list and point connect. I'm gonna show you point connect, how it works. So basically it's gonna iterate through the whole list in this cycle, right? It's gonna give to the helper here. This helper is gonna give the result of address finder. Address finder is a other function I have created, and takes 2 hint and 1 head of the linked list. So basically this while loop is gonna go through each point of the list, and then address finder is gonna do the same, looking for the exact match. So let me explain why this is very inefficient. So let's say we have a map like this, right? Okay, there's the maximum. So a linked list will link the points like this. This is the next, then it would go like this, right? But that's not what we want, right? So in my idea was create a way to link this point over here with the one down. So there's the need for the pointer call go down, and then we need the pointer go right, was in this case this one. How I was gonna be able to look for the go down, I wonder, like, and this is where things get messy. So each point has its coordinates, right? So basically if this has 0, 0, right, and I need to go find the address of the nodes that have either 1, 0 or 0, 1, right? And I have to do this for all the points. To Chrome, here you can see in this Y cycle I set up the loop with the address finder where X map is 1 time +1 and then update, and then he's gonna find with Y map +1. So this means in this case, for example, 0, 0, right? This point over here, and we won't connect to this point and this other point. I'm gonna call the function with X map +1. So the X is gonna be 1 and the Y is gonna stay the same as I show you here. X is gonna be +1 and Y is gonna stay the same, and then it's gonna do same thing for Y map +1 and X is gonna be the same. So same thing other. Address finder, it's basically gonna do another brute force for this. Address finder simply going through the entire list, finding the exact match between the 2 coordinates, and if it doesn't found it, just simply return null. And here you can see why it's not very efficient, this solution, because let's say you arrive to the last point, right? The last line here, those points here have all null, right? because there is nothing over here. Same thing for the last row here. It's still gonna to iterate through the entire list, try to find, and then at the end of the list is gonna return null. So you can see why it's very inefficient. But despite that, I already show you my project. It's a working project, so it works. It's just very slow with bigger map. Try to explain without going too much into details. I'm gonna show you. So after we understand how the map works, we are ready to using split or get next line, or if you guys have other ideas, you are free to do whatever you choose. We need to create a data structure. And inside the data structure, the important thing is we have a way to link the points in some ways. I decided to use the linked list, and then after we have these two main stuff, like these two things are like the main things you need to do. After that, it's just a matter of reading the documentation of MLX library, open up the windows, try to center the image to the windows, and then after that it's basically not so difficult. So MLX documentation, so you need of course to read the documentation, and then it's basically different if you try to do the bonus. I really wish I had enough time to try to make the bonus, but I was not able to do the bonus, so in my case I don't have no bonus. So basically these, once you have all the coordinates of the point, you have to start understanding how to work with pixels, windows, pixel windows, and images. Okay, let's take a look of the code and see how I was able to do that. Point connect is gonna return 0, right? We have this function that it's int to pixel, and here you can see I have a center and scaling. Let's keep this stuff in mind, because if we go back to the parsing function, we can see here space and scale. Okay, so I have to say ahead that this function was working without, before I was applying the isometric projection, it was centering very nice all kind of map. But after that, of course, the isometric projection changed the coordinates of the pixels, so it was not working as it should, but there is room for improvement. So this function space and scale is basically just gonna help me find the scaling, centering, to then go and give the right coordinate to the pixels. So there is a little bit of math. I don't wanna go too much into details, otherwise this video is gonna be extremely long. So here you can see I explain info to list what it was going to do. We have point connect, space and scale, that it's over here, and then int to isometric pixel. So let's go quickly to int to isometric pixel. So here this huge comment, guys, it was old Bresenham. So basically was this previous version without Norminet implemented. It was like 50 line long, something like that, and it took me ages to try to Norminet this stuff. And by Norminet I mean split it out in multiple functions, because as I already said in this video, we have to follow Norminet. That is a very strict indentation and indentation rules. But we have the function draw lines. One other key step I have to mention in the map, it's learn how to work. Like this was one of the key concepts of this project, learn the Bresenham algorithm. So Bresenham algorithm is an algorithm that helps you draw line. Okay, so guys, by the time I finish up recording and editing all this video, I'm gonna also update my GitHub readme, so you guys can see all the different stuff, the videos, all the resources I used. And as I was just wanting to show you what resource I used to understand the Bresenham algorithm. It's explaining and give you the demonstration on how the algorithms works. So basically, let's take a look at this GIF. You can see here is basically how to draw a line between points on a screen, basically, because those are pixels, those little square. And Bresenham algorithms is very efficient because it doesn't work with float points, it doesn't work with commas, it just works with ints. So that's the main reason why I think almost every people that did FDF choose these algorithms. But let's go back to the code. We have here int2 isometric. Here you can see there is pi, cosine, sine, basically just regular trigonometry for pi projection. Then I have my pixel put. This function is just taken from the 42 docs. Once again, guys, read the documentation because it's very important. I spent like 1 week or a dumb mistake because I wasn't reading the documentation. So yeah, basically here it's the reason why this function works like this. It's basically the image, it's just one big 1D array, so it's not like a multiple line array, just one big array. But yes guys, just read the documentation. Then we have draw lines, and as you guys can guess, in draw lines I just use the go right and go down pointer of my linked list, and I pass those to my Bresenham function. The Bresenham function is gonna take care of drawing the points. After drawing the point, I just have to make sure to free all the memories I have located, and that's basically it. So this was it for my project, and if you can find my GitHub over here. Once, like, I want to make clear one thing, I decided to make this video just to share my overview of this project, and because online there is not enough resources, I think, in my opinion, compared to the other project like Solong. So I know for sure my project it's not the best one out there. I see so many Git repositories with the awesome project, but for me, I was just proud I was able to get at least the mandatory parts done. So if you guys find this video helpful, it would make me very happy.